Hello, this lesson is about equation of circles. So to start, we're going to review the distance formula and where it comes from. So if I'm looking for the length D, the distance between these 2 points A and B, what would it be? So if I extend this, you can see, it's a right triangle. And then if I can figure out the length of those legs, then I can find the hypotenuse, which is D. So if we're looking here, we can see that this here, right here, is x1, and then x2 is here. Now remember, the subscript 1 and 2 just means here's the first x value and here's the second x value. You do not use it to calculate it, it's just to say that you have two different x's. So the distance between these two, how would you find that? Well, I would subtract them. Okay. And then what about the other leg? Well, if you're going this way, right? Here to here, we can see this would be y2, and this would be y1. So the distance between that would be here. And I'm going to put y2 in front to be consistent because I put x2 in front. So that point, those coordinates go first. So now that I have the lengths, using the Pythagorean theorem, I know that d squared, right, the sum of the two lengths squared. So that's one leg squared. Sum. Okay, using algebra. But this gives me distance square. I just want d. So that tells me I'm going to have to take the square root of both. So my final formula for the distance formula is this. The square root comes all the way across. So remember, we got to do the parentheses first, then square it, these parentheses first and square it, then add them together. So distance formula. All right. So find the distance between these 2 points. All right, so I'm going to write the distance formula here. You should have it on your paper. Okay. So most students use this first one as the first point, and then this one as the second point, but it really doesn't matter. The answer will be the same either way. The reason why that is because here, when you take that and you square it, if you do it one way, it'll give you a positive number. The other way, it will give you a negative number. But when you square it, it will be positive no matter what. Okay. So this is going to get me 13 squared. This is going to give me 6 squared. And 69 plus 36. Oops. Okay. I'm just going to double check my arithmetic. All right, and there it is. Now, it doesn't say to round, so this is my final answer. The square root of 205. Ooh, I should double check, see if I can reduce that more, and I cannot. The factors are 5 and 41. Both of them are prime. Right. Ooh, look at this one. Find the perimeter of a triangle. Ooh. Sorry. With a point, and here are the 3 points for the vertices. Round your answer to 3 decimal places. Okay. So to make my life a little bit easier so we can talk about them, this is point A, this is point B, and that is point C. So if I'm finding the perimeter, that means I have to find the length of AB. I have to find the length of BC. I have to find the length of AC, and then I'm going to add them all together. So how do you find the length? It's just distance. So you're going to use the distance formula 3 times and then add them all together. If I had a quadrilateral with 4 points, I'd have to find 4 of them, 4 lengths, pentagon, 5 lengths, and add them all together. Right, so it's going to take a little bit. So 4, oops, sorry. Keep doing slope. 1 minus 3. All right, to speed along things, I'm going to do things quickly. That's going to be 4, 16. That's going to also be 16. So that is going to be root 32. So I can see that's 16 times 2. So 16 times 2 is 4 root 2. Okay, so that's one of them. I'm going to round later. BC. It's 1. That's negative 5 squared is 25. Square 26. AC, so negative 1. Oops. Actually, it doesn't matter. I'm just going to. Like, why are you doing it first, Miss Mendoza? Why are you doing what? I don't know. But does it matter? No. It's not going to matter at the end. So this is going to be 1 plus 5. So that's 25. Do that right? 25. All right. Ooh, side note. So I've left it here. So here are my 3 sides. Well, look at this. Interesting enough. Hopefully I did this right. Those 2 distances are the same. The lengths are the same. So what do we know about this triangle? It's isosceles. Cool, right? All right. If I wanted to check if it's perpendicular, I would find the slopes. See if any of them were opposite reciprocals. Okay. So now we are going to round. So my answer is 2, right? Root 26 plus root 26. Okay, that's my exact answer. I'm going to leave it there. Put that there. So it's 2 times root 26 plus 4 times root 2. Okay. I said 3 decimal places. So it says 15.8548. So that's going to be rounded to 15.855. And I have no units. I'm just going to leave it like that. And there you go. Okay, moving along. All right. Circles of a plane, or in a plane. Equation of a circle. All right. There's something called conic sections. In conic sections, if you take a cone and you take a plane and you slice it in different directions through that cone, your cross sections would be these different shapes. So the first conic section that students learn is parabolas, and that's in Algebra 1. The second one we learn is circles. So let's look. How would you describe the position of a circle on a coordinate plane? So if you had a partner and you had to explain to draw a circle that you can see, how would you explain it to them? That it would be identical in size, shape, and position. Well, the 2 most important things for a circle is 1, the radius, right? So how that will tell you how big the circle is, right? Will give you its size. And the second thing, so the radius tells you how big it is. And then the other thing is center. The center tells you the position. All right, so how do we write these two things? Okay, so if I have here's my radius and there's my center, right? How do I find the radius? Well, the radius, it's just the distance, right? Radius is just a length. So if I use the distance formula, that would be great. So I can have a point here, x1, y1. But you know, because the center is special, I'm going to use different letters. And the different letters I'm going to use is HK. So radius is R and the center is HK. And H is the X value and Y in case of Y value. It is standard variables that we use HK when talking about the conic sections. You may have seen them with parabolas. Okay, so if I do this, we would say, okay, R squared, right? Just what we did before. Do the distance. And oops, I did that wrong. Sorry. We're going to do it this way. Okay. And then I'm like, okay, so let's look at this. Well, I put x1, y1 because that's what I'm used to, but do I need that since I only have one xy? Nope. So I think I'm going to erase that. So we're going to just say nope. And there you are. That is an equation of the circle. You're just like, that's it? Yep. Because it tells you the center, which is HK, and the radius. Now I'm going to leave it as r squared. So we're not going to put it in a square. I'm not going to take the square root. So this is the equation of a circle. Now, most places in books will write it this way. Same thing, they just put the r squared here. Okay. So let's use this. So I've written the equation on the top right so I can remember it and so you can see it and use reference up here. So how do I write the equation of a circle given the radius? All right, so here's my equation. And I'm going to, here's r, so but I need r squared. So I'm just going to square r, so that's going to be 9. So it is simply this, x minus 2. The minus comes from the equation itself, squared plus y minus 5 squared equals 9. And that's it. Okay, so over here, I have r, I'm going to do r squared. So remember, we're going to square each thing. So this is squared, which is 4. The square root of 6 squared is 6. So this is going to be 24. So it's x. Okay, now it's a minus and a minus, right? So what happens with that? So this is actually going to be a plus. Y minus 3 equals 24. There you are. Now, what if you're given a diagram? And you're like, ooh. So remember, I still need two things in my equation. I need the center and I need the radius. So I have my center. My HK is, my center is -2, 3. But what's my radius? I don't know my radius. So that's right. Guess what? We're going to have to find it. So using the distance formula, we're going to find the radius. So take my x's. So -2 minus 2. And 3 minus -2. Now, again, if you switch the numbers around, it shouldn't matter. If you did, you may get a +4 here, which is fine. And here you may get a -5, but when you square it, you should get 16 and 25, right? They have to be both positive. believe that's 41. All right, so r equals 41. So r squared equals 41. Now I'm going to use the formula. The negative and a negative is going to give me a plus. And then it's going to be a minus, again, because that's what's in the equation up here. And 41. So if you're not given the radius or the center, you have to find it. All right, now this one says find the center and the radius of each circle. Now you're going backwards. So remember, we're looking at this in this position. Okay, so now remember the sign, it was opposite. So remember here, I don't know if you noticed that this was a -2, but here was positive. So do you see that they're opposites? And this is positive here, but in the equation, it's negative or minus. So they're opposite. So now that I'm given the equation, my center is going to be the opposite. So this is going to be C for center. This is 3. Then you're like, Ms. Mendoza, there's nothing there. Great. What's the number that represents nothing? 0. Well, there's something there, but there's no number after y. Right? Now remember, this is going to be r squared. So you're going to have to take the square root. So r equals 3. Okay. So here, center, opposite, -9, opposite 7. Square root of 16, 4. All right, the center here, opposite, opposite. Oh, okay. Now we don't want a decimal, so what is that? Remember, we have to simplify it. The factors are 4 and 2. So that's going to be 2 root 2. Square root of 4 is 2. Okay. Right, not bad for these. Now, these next problems will be more complicated. They're not in this beautiful square form, right? We like it like this, but you're like, Ms. Mendoza, it's not even close. No, it's not. Now, in algebra, we do something called completing the square. So you're going to need your algebra skills from that to complete them, to write it in this squared form. So the way that we're going to do it is this. So we're going to take this, and if you don't remember, it's going to feel really weird. Because I wanted to write it like this. So to make it a perfect square, your quadratic, we're going to have to add something to that. So we're separating the x's together and then the y's. And you're like, what about the 3, Ms. Mendoza? Haven't forgotten about that. We're going to move it to the other side. It's just easier that way not to deal with it on the left side because you're going to be doing other things. Okay, so here where it's going to get a little crazy if you don't remember. What you have to do, you have to take the middle part. You're going to have to cut it in half. When you do that, the half of -6 is 3. So this becomes this here. Now, I need to put something here. I put a blank there. I put it there to remind myself I have to write something. If you don't, your answer is going to be wrong. Your radius is going to be not the right length. Now, to do that, you have the -3. You have to square this. So -3 times -3 is 9. Now, what you do to one side, you have to do to the other to balance. Right? So over here, same thing. You're going to take this middle term, you're going to cut it in half, that's 2, and then you're going to square it. 2 squared is 4. What you do to one side, you have to do to the other. You have to balance the equations. And then this whole part, you're going to add it all together. So this is 16. So now this is the equation of the circle. I should also say that in the directions I should also write the equation of the circle, then find the center and the radius. So now that we're in the equation, you can find it. So now the center is 3, -2, and the radius is 4. Remember, you have to take the square root. That is r squared, and I just want r. Okay, now I did a whole bunch of work over here. So now I'm a little squishy for the other side. I think I'm going to put it down here, though. Okay, so the same thing, you're going to separate it. You may want to watch this video again. Now there's nothing to add here, so we're just going to keep this 0, or just leave it blank for now. That's fine, because you know we're going to be adding things. Okay. So remember, we want it to look like this. Like, I already know that. That's the form. That's the way the equation. And you say, how do I know it's plus? Because this is plus, this middle part. If that middle part's a minus, like here, it's going to be negative there. It's part of completing the square. Okay, so you're going to take this in half. That's 5. 5 comes down here. Then you're going to square it. That's 25. Would you do one side? You do the other. Okay, let's try it again. You're going to take 14 divided by 2. You put that here, the half of it, and then square it. And that's going to be 49. Okay. And then you're going to add that, and that is going to be 74. So that is the equation of our circle. The center, okay, is going to be opposite, opposite. Radius, remember, take the square root of this. And there you are. So remember, it's called completing the square. You may want to watch maybe some other videos from other people to refresh your memory. Oh, I totally forgot about an EQ. Oof. Okay, so here's my EQ. You're going to be like, Ms. Mendoza, I didn't write it. Okay, it says answer the EQ. So my EQ is this. What is the relationship between the distance formula and the equation of a circle? Okay. Thank you so much for watching. Bye.